Hello! Today in the lesson we are going to solve another problem using an equation. Problem condition. Two pools. One pool has 1,600 cubic meters, and from this pool pumped out water at a rate of 65 cubic meters per hour. And in the other pool at the same time is only 1,215 cubic meters. And water is pumped into the second pool at the rate of 45 meters cubic. The question is, how long before the volume of water in these pools will be the same? We need to write the time in the answer. We will solve this problem through an equation. Notice that there's a certain amount of time in which water is pumped out of the first pool, and water is pumped into the second pool, and we need to find that time. But the condition that the volume of water in these pools becomes equal. We can guess right away that in order to write the equation, to write down the equation, we need in the first condition, equality of volume. So I'm putting the equal sign. And now we have to write an expression on the left-hand side and on the right-hand side, which will tell us what happens to the volume of water in the first pool and in the second pool. The volumes of the first pool and the second pool should be equal as a result. Let's talk about these volumes. If water is pumped out of the first pool, is pumped out of the first basin and water is pumped into the second basin, then there is some particular point in time at which the volumes will be equal. If we need to find the time in the problem, then we're going to denote the unknown quantity as t. As a result, what do we get? If the volume of water that is pumped out of the first pool is 65 meters cubic per hour, then in a certain amount of time of water, 65 times will be pumped out of the first pool. Then if water is flowing into the second pool, then at the rate of 45 meters cubic per hour, then I can write down that the volume of water that's going to come into this pool, it will be equal to 45 times t. But from one pool the water flows out, that is, there is less of it. So I'll write down 1,600, that's the same volume, minus 65 times t, that's also the volume. The second pool has more water coming in, so I'll write 1,215. But plus 45 times t, the result is that we have an equation. When you get an equation, you need to be sure to check. 1,600 is the volume. 65 times t is also the volume of water, which is the volume of water that's going to come out of the first pool on the right-hand side. 1,215 is the volume, and 45 times t is the volume of water that will enter the second pool. And only after that we can solve the equation we got. We've got the equation. We've checked that we have the volume on the left-hand side. This expression represents the volume, and the right-hand side represents the volume. And now we're going to solve the equation. Let's rewrite it. 1,600 minus 65 equals 1,215 plus 45t. And now we apply the algorithm to solve equations. We collect the variables in one part and the numbers in the other part. What am I going to do? I'm going to put the numbers. On the left side, minus 1,215 equals 45 plus 65t. Now let's solve the resulting equation. The result is 1,600 minus 1,215 is 385 equals 45t plus 65t is 110t. Now we can find TT equals 385 divided by 110. And when you divide 385 by 110, you end up with 3.12. Our time equals 3.12. If we're talking about the velocity, 65 cubic meters per hour, then the time is 3.1 hours. And then we can say that time is either 3.1 or 3.5 hours. Or we can say it's 3 hours and 30 minutes. We've solved the problem. And we solved this problem with an equation. In the next lesson, we will solve another problem. And for today, our lesson has come to an end. Goodbye. See you again.